Good afternoon, or still morning on the West Coast if you're joining us from there. I'm Matt with CTI Connect, and I have Derek Underwood with Cambium Networks and Anthony Holmes with us today. We're going to wait for a couple more minutes for people to come on into the webinar, and we'll go ahead and get started in a couple minutes here. If you do have any questions before we get started, feel free to ask them ahead of time in the chat box, and feel free to ask questions as we move along today. And looking forward to talking with you about a little bit about the Cambium Network 60 gigahertz solution. And we'll get started here in a couple of minutes. All right, we're going to wait one more minute here and let a couple more people get in, and we'll go ahead and get started with the webinar. Okay, welcome everybody. I'm Matt Kale with CTI Connect. I'm a senior account manager over here. Today on our webinar and our Wireside chat series, we have two members from Cambium Networks, and we're going to be talking about their 60 gigahertz Telegraph solution. We have Derek Underwood and Anthony Holmes. CTI Connect is a distributor for Cambium Networks. We have warehouses in various places throughout the country. We've been working with them for a long time. We have stock of this equipment on the shelf, ready to ship today, which is kind of an interesting thing to be able to say at these times. But we're ready to help you out with their equipment. And today's rough agenda, so feel free to interject, ask a lot of questions. We really, we're here for you guys, so make sure that anything you want to know about their portfolio, feel free to ask. We have a pretty loose agenda, and we're going to go through some Q&A and talk a little bit about the product, but also we're going to go through the roadmap further on, and we'll kind of make this a more casual thing. So the more questions we get, the more specific knowledge you can get about their product. If that's all right, Derek and Anthony, you guys want to introduce yourselves?
Go ahead, Anthony.
Oh, okay. So hello, I'm Anthony Holmes. I'm VP of Engineering, and I look after the millimeter wave product group for Cambium Networks. I'm based in the UK. I've been in wireless for around about 27 years. I'm a founder member of a small company called Piping Hot Networks, turned into Orthicon Systems, and has evolved into Cambium Networks over the years. So I've been doing this for quite some time, and been involved with a lot of wireless technology. So keen to answer your questions.
Thank you.
Thanks, Anthony. Well, I also go back to the Orthicon system days with Anthony, and have been a part of the organization really since inception and divestiture from Motorola. I manage our North America go-to-market team, regional vice president for North America, and I'm based out of Colorado. So look forward to some good dialogue today. This is without a doubt the most exciting launch that we've had in recent memory. And I think we're seeing very early adoption and a lot of success that customers are having with this technology. So I'm looking forward to, again, some good dialogue, and certainly looking forward to Anthony sharing some good info with us.
Excellent. So kind of from the beginning, a lot of people are brand new to 60 gigahertz, millimeter wave, Telegraph, and all of this. And so, if we could kind of start by building a little bit of a base. Anthony, can you speak to a little bit about what is Telegraph and why Cambium's using it, and how it ties into your software and hardware with the CN Wave product, which is Cambium's 60 gigahertz offering?
Yeah, sure. Okay. So 60 gigahertz has been around in products for 10, even 12 years. We looked at it at Motorola back in 2010 to see, should we get involved in this? At the time, it just wasn't right for us. It wasn't ready. So we held back, and we've been keeping an eye on it, on the technology. And 11AD came, it still wasn't right. And so it was really when Facebook, through TIP, started promoting Telegraph and the start of the .11ay standard. So we got involved in Telegraph back then in 2018. And we've worked with Meta on different aspects of the system throughout that time, and brought to market basically the product through that. Now, what I see Telegraph as is really an ecosystem of different aspects from layer 1 to layer 4. We'll go into that a little bit later. I see that as offering a way of building a construction material really for wireless networks. So it's not just about the wireless, but it's about how to put the network together. It's how to put the management together. And this is the beauty that a bunch of OEMs, a bunch of vendors have all got together, worked with Facebook, and come out with this ecosystem to enable your customers, our customers, to deploy this technology. And we've seen now in the market, people have taken many different approaches of how to do this. We'll see Telegraph radios. Some vendors will come out with just a single 90-degree solution. Others will have 5 DNs covering 90 to 360 degrees. Others will just have one 360-degree DN. Now, what we did was, and that's really based on the reference design from Facebook, this 90-degree sector approach. Now, what we did is we looked at this, and originally back in 2018, we were going to go with 90-degree sectors and sort of deliver the product like this, but what we did is then we took a look at all our other deployments. As you know, Cambium Networks has sold around 7 million radios throughout its sort of history. And we have a thing called Link Planner. Link Planner is a great planning tool, free of charge from the website. But we actually plan in that Link Planner tool around about 2 million radio links a year, at least 2 million a year on this planning tool. So we took a look at, well, how do people use radios? And I know propagation is different between 60 degrees, 60 gigahertz and 5 gigahertz or 3 gigahertz. But actually what we saw is when you look at the ranges, what you saw is when you look at how many houses you could see, or how many radios you can see from a single point, from a micropop, then we actually saw that you don't see that many buildings. And especially with 60 gigahertz propagation, with it being line of sight, the availability affected by oxygen and, more importantly, rain, the number of subscribers you can see from a single point is going to be low. The next thing is well, where are you going to deploy it? Are you going to deploy it on poles? Are you going to deploy it on rooftops? Are you going to deploy it on street lamps? So with all that in mind, we actually took a different approach rather than having the single 90-degree. And we went for a diversity approach, as it's called, where we combine the tiles inside the actual radio to not just cover 90 degrees, but to cover a wider scan range as possible, the 140 degrees that we have. And by having two of them together, we cover 280 degrees. Now, this offers you a very nice sort of shape to, the Pac-Man shape, or, the pie shape, which at the end of the day, that the part that's hidden from view is normally where the pole is, where the mounting point.
Yeah, very narrow. So there's just a 80-degree wedge that's not being covered at that point.
That's right. So what we took into account is, well, we don't want to waste any energy. We don't want to waste any, we don't want any reflections coming back at this point. We don't want the energy just to go into a wall or just go into a pole. So that's why we took this approach and came up with what we felt was a way of offering a product low cost with low energy. Doesn't take, you're not actually heating tiles up, which is not going to be used, and supporting those 30 clients from a single subscriber unit was about right for the range that we have and the deployments that we saw at the time. Now, since then, we're actually proven we got it right, I believe. And I think if people take a look at this, they will find that most of the time, they will not be able to use that 360 degrees. 90 degrees is far too narrow. And, the sort of compromise of, well, not compromise, but the optimized 140 degrees per sector is, gives you that flexibility to connect lots of people with just a single device.
So you've thrown out a lot of things there. So I'm going to kind of try to backtrack a little bit on those. We'll start from the basis where we mentioned the original chipsets that were out was the AD chipset, and Cambium made the decision to hold off and utilize the next generation chipset, which is AY, which is what you guys are utilizing today, and utilizing the Telegraph overlay on that. Can you speak a little bit about the capabilities of that chipset and why it works well with your guys' plans and with the Telegraph protocol?
Well, I think this is where it comes down to what Qualcomm has put together as part of the 11AY standard is gives you a lot more resilience than we had in AD. The whole idea of being scalable, being able to deploy in dense environments is all being driven by that layer one and layer two improvements they've added with the TDMA, TDD, synchronized TDD access, the block coding ALQ, the additional link adaptivity modulation modes that they're offering, all means that you're getting far more bits per second per hertz inside that large bandwidth. But then add power control on top of that, which means you only use the power you need to achieve the maximum data rates. You're not screaming and shouting all the time, deafening everyone around you. If you can actually achieve the link that you need with a lower power, it will adapt down to that lower power. So all these things that have been put into that standard to make it more friendly to others around it has made the Telegraph or AY chipset far more usable than the AD chipsets.
So, like the next step from there, there's a couple different products on the market that are, using the Telegraph chipsets and the Telegraph language and some pieces of it, and they're using it in some pieces they're not, and there's some capabilities some people have and some don't. But there's Telegraph certified, and then there's fully compliant, and there's seems like multiple different iterations of everywhere from just using the basic hardware to everything. Can you talk about a little bit about Cambium's approach on how much of this you guys decided to implement and going compliant, and how that benefits these end users utilizing your solution.
I think there's, when a standard comes out, there's a lot of things in the standard which are mandatory. There's a lot of things in the standard which you can use if you want to. And the way that Telegraph's not a standard, as I say, it's an ecosystem. A lot of it is being utilized in the standard of AY. But I think, as I say, a lot of effort has gone into making sure that that ecosystem, all those pieces together, gives a resilient system. So Telegraph certification comes into 3 stages. It comes into the sector approach, the sort of the node approach, which are you using the chipset? So you will see products out there which use the chipset, and therefore they will say, yeah, well, sure, we're Telegraph certified because we're using Qualcomm's chipset and we're using for the baseband and the RF. But that's it. That's the only thing they utilize. So that they are getting that layer 1, layer 2 technology, and they are getting the beamforming capabilities that you get from the QCA chipset, etc. But then you've then got above that, you've then got you've then got the next layer above that, where nodes can talk to each other. So nodes can interact with each other, where you start looking at the layer 3 protocols come into it, the OpenR technology, for example. So OpenR is a meshing technology which is driven by Facebook. Facebook created this and is utilized in their data centers. And it's actually using a layer 3 routing in order to every single node has a database inside it, knowing the path that it can actually get out of the network using. So using keeper lives, it actually talks to each of the nodes around it and understands the modulation modes that they're using, the path lengths to the POP, etc. So it can actually calculate the best route out. And this is the sort of layer 3 side. And then you've got the network layer, as far as compliance is concerned, where you then can utilize things like ECMP, equal cost multipath, BGP routing, and all that technology to actually then share your capacity around that whole network. Now, what Cambium has done is utilized all that technology. So at all layers, we are compatible with that ecosystem. We're taking that ecosystem on. Now, what you get from that is not only the sort of knowledge base of multiple vendors sort of saying what the best approach was for networking, what the best approach for radio is concerned. You're getting all that technology, but then we're then building on that. So not only are we offering, so it has all been designed around IPv6, for example, but now at a press of a button, you can turn that into a layer 2 IPv4 network. And with the latest software that we have with 1.2, you now don't need any knowledge at all of IPv6. So to a user out there using this system, they can come along, put this mode into a layer 2 mode using IPv4 to the outside world. But inside, we're still using all that layer 3 routing technology. We're still using BGP. We're still using dynamic prefix allocation to keep that network alive and running and operating.
So kind of what I see, I talked to a decent amount of these operators out there, and they got this and they got that, and they tried a little bit of everything. And one of the things that I keep hearing over and over is that Cambium has a solution that you can scale with. People had gotten stuff to test, and they'd put up a base node on this at the tower site or the main POP site, and they'd put out their subscriber modules and the DNs, and they would be able to hook them up, but it just kind of ends at that hub and spoke mentality with a lot of other products. And I just hear over and over with people, hey, I'm using the Cambium CN Wave, it just works. I don't have to, you're plugging in all these different your DNs or the V5000s, you're plugging all these in, and they're automatically hooking each up to each other. They're automatically meshing. They're already doing the load balancing, as you're mentioning, the BGP and everything, all internally with that IPv6. And so from a user's perspective, it's, as close to plug and play as you can get with a very complex backend routing algorithm. Can, you speak to, obviously you guys are doing it this way and people are happy and it's working well. Why is it that your equipment is able to do that and other people aren't?
I think that's because we have taken on this ecosystem and got it to work. I think that's the difference. The scalability, this is what I love about the product, is the scalability goes from point-to-point link. You can create a point-to-point link out of here using V1000s over 100 meters, or you can use a V3000 over a kilometer. But you can then go on to, as you say, the hub and spoke. And this is how many people in the past have dealt with point-to-multipoint. As you know, well, products like EPMP or massively MIMO Medusa with Canopy, all use hub and spoke approach. And you can do that with 60 gigahertz. But then we offer that next dimension, which is the distributed network. And this really is what makes 60 gigahertz work, because this is how you get that area coverage. And as you say, the beauty is it's not, you don't create your network and then switch it on and just press a button and go. You actually grow your network. And this is the beauty, is that when what we see with people, they come along day one, put that POP up. They get the POP working with the management system. And then you just keep on adding and adding in units. And we see this whether it's in cities where, we saw a city over a couple of weeks put 100. Malaysia, for example, is now put 250 units up it took them 4 weeks to put a 250 link network up. But it's just by putting units in every day, making sure the network's up and running, carrying on, and then moving on to the next one. There's no big bang. And the beauty about the routing inside, it self-heals itself. It knows about itself. It knows where, if something else comes in, it will rezone itself so that you can actually, utilize multiple POPs. Because that's another thing about this. It's not just a single point of entry anymore. You can have multiple entries into your network, and every time you put one of those entries into your network, your capacity leaps up by another 3.8 gigabits per second. So as your network grows, you could just drop in another POP and get that extra capacity. So you either give yourself resilience by giving you another path out, or give yourself extra capacity by adding these POPs in. And it's all down.
I just wanted to also, there's a common misconception, I think, from service providers and customers out there in general, that they're going to select one manufacturer, or if I want to do something simple with layer 2, I'll go with manufacturer X. If I need the meshing capability, I'm going to look at the cnWave platform. And I think it's an important point that Anthony made, that we look at the meshing capability and the OpenR technology as what really allows this system to scale and deliver the performance. But we really make it simple to do a small layer 2 network for video surveillance application. So it's not, the product doesn't have limits in terms of cnWave is only for large scale networks. We do have very simple deployment in the layer 2 scenario, but we also recognize that long term, we think customers are going to need that layer 3 capability to truly scale and take advantage of some of the multiple POPs and the resiliency and all those things that Anthony talked about. Because this is a completely different system design and architecture, because we're so used to putting up a radio, as Anthony mentioned, 100 foot up on a tower and seeing how far we can get that signal to propagate. And we've got limitations here that are not typical of a 5 gig system or a 3 gigahertz system. So we have to look at the design completely different.
Sure. So I guess this is probably a good time. I'm going to put up a poll here. One of the things that, I think we all want to convey as part of this is that the Cambium network solution, if you've used something else before this and maybe been banging your head against the wall, that they have the easiest and the most scalable solution. And part of our question is we kind of want to get a pulse as to, how much experience people have with the market and what product you've used, if you've used something else, or if you're just kind of starting from zero and looking to select what vendor you want to start working with this equipment on. I did get a couple of questions. They're probably more geared towards roadmap section, kind of like future development questions. So I'm going to run those questions from attendees by you guys at that point. Talking about the ecosystem with the Telegraph being fully compliant and a little bit about your hardware. Anthony, can you talk a little bit about how end users are going to be managing this platform? Do they have to remotely log in each individual unit? How does somebody start deploying this and manage the equipment?
Well, I think that's another part of the ecosystem is the management side. And how this is managed is through a central manager, a central controller. Now, this central controller can operate on a DN, or it can operate externally on a virtual machine. Now, this central controller is really the way we can configure the whole network. What you would do is you would configure the network, you configure the parameters on this central controller. At that point, that's the only configuration you really need to make on any radio. When you go and deploy this, it's all been sort of pre-done on that controller. We'll talk about the future. We are looking at even making it simpler. But currently, you put all the information on the centralized controller. You hand the job ticket to your installer and say, here's your GPS coordinates, go and install that unit at that GPS coordinate. They go out, they will put the unit up there, make sure they have line of sight to a distribution node, and pretty much that's it. At that point, the radio, put the power on the radio will then spark up, it then ignites, it then talks to the distribution node, and the distribution node will download the configuration, download the latest software, and bring it onto the network. And pretty much that's all they have to do. If you are, the only time you would have to do any configuration on that unit is if you have a certificate. If you want to use 8021X certificates for wireless security, you would have to put the wireless certificate on that unit. But otherwise, your installer doesn't have to actually do any configuration. So we're trying to make it as simple as possible for those installers. Now, using this centralized controller. Now, you might think that's a single point of failure. However, if that centralized controller goes down, it actually doesn't affect your network working at all. Your network will carry on working. The only thing you can't do is add a new radio onto your network until you've sorted out your controller. But that's something that's under your control. You can do that at any time. You can have that controller at your NOC. You can have that controller in a secure place, safe place. Once that's up and running, you can carry on. If you're running that controller on a DN at a POP, if you have an alternative POP, then even if that POP goes down with that controller, all the traffic, because all the information about routes, all the information about the mesh is all contained in the individual nodes, they would just reroute themselves automatically and go out via another POP. So there's no single point of failure with that controller.
Okay, thanks, Zeb. So, and that's all done through your CN Maestro system then?
Well, CN Maestro is on top of that. CN Maestro is actually used as the network management system to integrate and talk to that centralized controller. But of course, as you know, Maestro not only does that, it will talk to all the Wi-Fi devices that are attached and being backhauled through the CN Wave, or it will talk to the devices in the client devices indoors as well, all under that single management system. So it's all integrated into Maestro. Yes.
Perfect. I think maybe now's a good time to talk a little bit. There's 3 radios today in the portfolio. Do you want to talk a little bit about each of those radios in its intended purpose, and also then make a transition into discussing a little bit of, the future plans of the product portfolio. CN Wave, or Cambium's very invested in CN Wave, and if you could talk a little bit about where you guys plan to go with the portfolio.
Okay, so as far as hardware is concerned, we have 3 models currently. So we'll start off the V5000. The V5000 is a distribution node. As I was mentioning, there's different models of distribution node you'll find with Telegraph. This particular one will cover 280 degrees in a pie-shaped arc from a single point. Each one of those sectors, 140 degrees, can get, at this moment, with just a single channel, can get around about 3.8 gigabits per second by directional rate. In the future, we're going to add channel bonding, which will allow you to go up to around about 2.6 gigabits per second in each direction, around about 5.2 gigabits, maybe 5.4 gigabits per second on each sector. So that's with channel bonding coming. So there's a lot of capacity in that just single radio there. Now that is called a distribution node. These distribution nodes, you would scatter those around either on building tops or on lampposts, or you would scatter those around that area to flood an area with 60 gigahertz. Then on top of that, then they all talk to each other. You then have things called client nodes. Now, these client nodes are used to be put onto your customer premises. And we have 2 of those. We have a V1000. This has a gigabit interface on there. This is your low cost, sort of medium range, medium to short range residential radio. And then we have the V3000, which is capable itself of doing around that 5.2 gigabits per second from itself. We have that, which will do longer ranges. Now, the ranges that can do, it can get that 3.8 gigabits per second bidirectional rate with a single channel now at around about 600 meters. It can actually go many kilometers. We've actually got V3000s out there which are going multiple kilometers, 2-3 kilometers. But it's all about high speed and a lot of throughput. So they're the 2 client nodes that we have. And on that V3000, you actually have an interchangeable dish on there, which will either give you the 60 dBm EIRP or around about 55 dBm EIRP. So it just gives you a little smaller form factor with the smaller antenna.
And Matt, we've got some customers that have gotten creative. They've started implementing networks using DNs everywhere, because really there's no limitation. You don't have to use the CNs at customer prem side. Certainly the DNs are we're seeing more and more networks being deployed with higher density of DNs.
Okay, yeah, that makes sense. I've seen that a lot with customers lately, is that they and we'll get into a little bit more applications at the end, but while we're on the subject, where people are doing a lot of V5000s in their initial deployments, even if it's not at the pop, but they're doing a decent amount of V5000s. And then once that kind of initial mesh network has been built that has the resiliency, then they're kind of filling it in with the V1000s, and if something's pretty far out, maybe a V3000 to connect to the backhaul. And that V5000, the DN ratio is pretty high to the CNs initially, but as you roll out, you're adding more of those CNs to once it's been built out.
I think what we're seeing is if you have this distributed network, you'll have a lot of those V5000s, and that's the whole point. It's a shorter range. You put these out to actually flood the area. In hub and spoke arrangements, what we tend to see is you want to be using a V3000 as a client node. So you might have a single DN, and then you have V3000s hanging off that, up, as I say, up to around about 600 meters. You get that 3.8 gigabits per second bidirectional rate.
Okay. you mentioned there's some little bit of roadmap you want to go through on this. And I'm sure that's why a lot of people are here. They want to hear where the product is going in the future. What can you tell us?
Next year, you will see there's going to be a couple more client nodes coming out. And these client nodes are about getting more capacity as far as low-cost capacity. So we'll be getting better, higher throughputs, maybe using a 2.5 gigabit interface rather than a 1 gigabit interface on that low-cost residential unit. And then we're looking at a smaller, compact, high gain antenna. So this is something that will be around about 48, 50 dBm AIRP, and that will actually go right between the V1000 and the V3000 as far as range is concerned. High capacity, high range, compact to be put onto a customer premises. We will leak more as we go through the first half of the year, or first quarter of the year.
I got a question that came in a little more on the technical end. Customer says they've chatted with a couple RTMs on the service provider network architecture and what's needed to support CN-Wave in its current iteration. And it seems like a bridge network eliminates the need for the GRE concentrator, albeit at the expense of performance, reportedly until the next major release. At what point on the roadmap does the need for a bridged outside plant network go away? Concern is scaling constraints associated with bridging.
Right. So the GRE concentrator, you don't actually need to have a GRE concentrator for most networks. A lot of people, a number of people have used a concentrator more for the control they wanted to have over their network, over their clients. For most people, the GRE concentrator can be done at the POP. So each POP can act as, when I say POP, each POP distribution node can act as a GRE concentrator. As far as the performance is concerned, at this moment in time, yes, there's a performance hit with the GRE tunnels. We lose around about 15% of the throughput. So instead of getting about 1.8 gigabits per second, we're around about 1.5, 1.6 gigabits per second in each direction. Okay, it's about so it's around about 10 to 15%. Now, the reason for this is we are in a thing called kernel mode in Linux. So to cut a long story short, it basically means that we touch every packet. We are now developing VPP DBDK, which is a way of handling packets, a fast path in Linux. So it's used commonly around the place, and a number of vendors are already using this. We'll move to that, and it just basically means we get back the loss that we have by looking at each one of those packets. But I would still recommend people use the concentrator inside your POP-DM. All right, you will not notice that difference in the packet performance. And as soon as the software 2.0 comes out, you will lose that. You will gain that capacity anyway, but you won't notice any difference, and it's far easier for you to manage, far easier for you to look after your network. It also gives you resilience as well, because instead of having a single GRE concentrator back at your network, you have multiple GRE concentrators. So a tunnel, when it's built up between your CN through your distributed network to your POP, if any one of those links goes down, the technology is still there. The tunnel will just reset itself to the next best POP. So there's no loss of resilience by using GRE tunnels, and you only get that by using the POP concentrators.
Thanks. I'm going to share the poll results here. We had a lot of people participate in them, and the surprising thing that I'm seeing is a lot of people have used 60 gigahertz, but not used a Telegraph solution yet. So I'm happy that we kind of really talked a little bit about, why you'd want to utilize Telegraph to have a scalable solution to deliver a large amount of bandwidth to also a large amount of people. Part of what we're getting into is, Derek, you hinted at a little bit that there's some small scale camera deployments to citywide deployments to residential providing gigabit to the home. Can you guys take a little bit of time and talk about some highlighted projects that you can think of that are success stories that people on this call can hear about, and maybe will trigger them to go after a particular market?
Yeah, sure, Matt. I'll take an initial crack here. We've got now this technology is no longer a new release for us. We've got thousands of nodes deployed. We've got networks that have been fully functional and operational now for the better part of the year, that we've really seen an expanded set of applications. And I think that's one of the unique aspects of this technology. We deal with customers all the time that they're very averse to unlicensed technology, concerned about interference, concerned about the security aspects of it. With this technology, it's so unique in the sense that the ranges are so short, which certainly has its challenges, but also gives us the benefit of very high frequency reuse, gives us the ability to deploy some very dense networks. So we're starting to see service providers move into more urban environments where they're competing with cable. We have a service provider in Perth, Australia, called Pentanet, and they've got they're deploying over 130 CPEs per month. They're at a very rapid clip, right? And I think when you look at this technology and say, my other alternative to get these types of speeds is to trench fiber, how quickly could I hook up 130 customers by trying to tap into that dark fiber? And in Pentanet's case, they do. There's about 300 kilometers of dark fiber that surrounds the town of Perth. And so this is a great way to overlay an existing 5 gigahertz network for, to meet those increased capacity requirements that customers have, using a technology that you can deploy at that rate. So that's a unique one. It's going very well. It's also a rapid deployment scenario. We're seeing lots of customers converted from 5 gig to 60 gig. We had a lot of success with the city of San Jose. And I think, with all of the government funding that's coming down to support digital inclusion, economic stimulus, the broadband movement is certainly in full effect in North America and around the world. And, city of San Jose, as part of this digital inclusion project, really they've been deploying, they're using the C&Wave solution to backhaul Wi-Fi, which is unique. I mean, it's, we've seen over the years, we've had aspirations that cities were going to start deploying mini Wi-Fi networks and free Wi-Fi for all. And I think we're at a point now where, as a result of the pandemic, and again, the government stimulus funding, we see cities like San Jose that are saying, hey, we're going to go invest in backhauling this mini Wi-Fi network to help bring broadband to areas and communities that are underserved. So I think that's an exciting one, because obviously city of San Jose is a big city that's growing. Obviously lots of technology there. It's also the fact that it's backhauling a Wi-Fi network. Cambium, we have made the decision to put a lot of investment dollars into our enterprise portfolio, and even expanding into the outdoor as well as indoor space. And so I think, again, this is a good, this marriage between the Wi-Fi and the 60 gigahertz C&Wave technology, I think is one that's got a lot of merit moving forward for cities across the country.
Yeah.
We've also, go ahead, Matt.
I was going to say, I have some experience with the new Wi-Fi 6 outdoor radio, and it's an absolute behemoth what it can do when it comes to range and performance and speeds, the XV2T outdoor. Can you talk a little bit about, we're talking about marrying these two products. I've used one, I've used the other. can you talk a little bit about how easy it is that they would interact with each other when it comes to powering data and management?
Sure, Anthony, you want to take it? Or?
Yeah, sure. So there's actually multiple ways we can do this. The V5000 has a aux port on there with PoE out on there, and that can power the Snow Leopard, so the Wi-Fi 6 device. We've designed it to work together so that the Snow Leopard and I keep on saying it, the Wi-Fi 6 device and the CM will work together and provide that backhaul. The other thing is actually the outdoor devices themselves, the Wi-Fi outdoor devices, have PoE out on them. So this is where if you want to use the V1000, you can actually power the V1000 off the Wi-Fi device but still use it as backhaul. So we're offering the user both capabilities here to either utilize something like the V1000 to create the backhaul network for the Wi-Fi device, or use the V5000 in a distributed network like we see in the smart cities, powering these Wi-Fi devices to put get the backhaul back to the POPs. So we're doing both, and then on top of that, you've obviously got CM Maestro, which is managing both. It can see both the devices, it can manage both the devices. So it really does enable you to combine all the Cambium technology, whether it's Wi-Fi 6 devices, the CM Wave devices, CM Matrix, to then the switching technology, all under that CM Maestro.
And Matt, I think it brings up a good point too. We obviously as a large supplier of microwave technology, we've always looked at microwave as sort of as the backhaul play. And what we're seeing now though is that the technology that we're actually backhauling in some cases is exceeding the capacity of and capabilities of our microwave radios. So that's another area where we're starting to see CN Wave as a potential solution, as truly providing an injection layer of backhaul for some of these higher capacity technologies that, frankly, an 11 gig or 6 gig radio, obviously much different distances, but can't deliver those types of capacities. So it's, this is not just a customer prem residential broadband solution. We're seeing it for video surveillance applications at airports, where they're putting eyes on fuel depots. And we're seeing this in oil and gas, in rail yards. I mean, think about, rail yards and how much data there is that has to come out from a security standpoint, from a video surveillance standpoint, and how difficult it is to get right away entrenched under railroads. And obviously this technology enables those high capacity, highly resilient, reliable networks, where you just need that extra extension from your fiber network, but it may be too prohibitive, either cost-wise or time-wise.
Yeah, it's amazing that you can rapid deploy this product on the same time and not have to worry about the time they're going to be spending trenching the fiber, and all the permitting with some of these projects we've been working on has been, it's just hearing these people not have to deal with the permitting anymore and being able to, say, oh, I get this and I can deploy it tomorrow. It really gives a lot of these managed service providers we're working with a huge step up when it comes to their competitors and how they're viewing projects. I was talking to somebody that was talking about trenching fiber 10 feet in New York City, and it was going to cost them $30,000 to do that 10 feet. And it was just mind blowing, how something as simple as your guys' product could have them the same week, have that project done and under budget.
Yeah. And I think we're also seeing people look at this technology because of some of the lead times that we're seeing on fiber, on glass, on the boring equipment, on all the things that go into deploying fiber. Some of the lead times are out to 52, 54 weeks. And so, we're seeing people say, I can't wait, to hook customers up, or I can't wait for the ground to thaw out for me to go hook these customers that are underserved or unserved. And so I think that's, again, another place where Telegraph and CN Wave plays a huge part.
I do have a couple more questions. One of them was, is there a practical limit to the number of GRE tunnels to each POP DN? Now in version 2, when the DPDK module is made?
No, there's actually no practical limit for the tunnels other than the number of devices that you can support on that distribution node. So each sector supports 15 of those nodes. So that's all the tunnels it has to support, right? So there's actually there's no actual limit on there. At the end of the day, it's about the number of packets that you deal with. And that stays constant. You will deal with 3.8 gigabits per second on each one of those sectors. So not now, not even in the future, is there a practical limit.
Perfect. Another question that came in, somebody was asking about in other countries outside North America. If anybody does want to know who their Cambium RTM would be, the regional technical manager, or the RSM, the regional sales manager, you could funnel those questions to us and I'll answer those offline and put you in touch with the right people. Something that I want to express about Cambium networks that some other companies don't have is that they have a sales staff and a technical staff that can help you before, during, and after your deployments, so that you're not just on your own going to a forum to kind of figure out what kind of speed bumps other people have gone through. Derek, can you talk a little bit about the Cambium sales channel?
Yeah, absolutely. Obviously, Cambium we have an indirect sales model. With that being said, we engage quite a bit with end users. We have North America has a team of regional technical managers that are our version of sales engineers that are really there to support a lot of the design and POC work that we're doing. We've had a POC program in place that Matt can certainly speak to in terms of the details. But that POC program has been very successful. While we try to provide good documentation and make it easy for customers to deploy, we do have a team of sales engineers to support you should you have issues. And then we have our distribution network, which is a critical piece to what we do in terms of not just having product on the shelf, but having expertise, having the ability to support some of the simple questions and the out of the box questions that customers may have. We also have a pretty large VAR network, which is our value added reseller community that really focuses most of their energy on buy sell into the enterprise markets, industrial, public safety markets. And they're able to take this technology and combine it with cameras and analytics and sensors and really create a solution as opposed to just providing a box. And so I think that, that ecosystem that we have from a go-to-market standpoint provides our customers with a lot of benefit, and also gives it enables a lot more than just deploying a radio. One of the things too, Matt, that we haven't talked about is how much work we've put into our see and heat planning tool. Because one of the challenges that this technology has.
Just had two questions come in just about that. So you just had the perfect transition.
Excellent. I didn't even, I'm not sure who Daniel Benson is, but he's my straight man apparently. But yeah, so I think, one of the challenges is designing a network when you have DNs and CNs and there's some really interesting PowerPoints and coverage maps that we've done where we show the difference between what a high site design would look like versus 7 DNs in a neighborhood, and being able to cover 50 to 60% of the neighborhood versus 95%. So I think see and heat is a huge enabler for that, because it is challenging in many ways to design these systems without tools like see and heat and link planner. Anthony, I saw another question. Are there plans for PTP CN wave in the upper 5 and 6 bands?
Is there? Okay, so at the moment, the portfolio will do channels 1 to 4. As far as point-to-point is concerned, there is no Telegraph product that can currently do channels 5 and 6. So we are working actively on the next generation, future, which will be looking at the .AY standard, and looking to see whether or not we're going to introduce that and when. As far as channels 5 and 6 are concerned, I can understand for point to point, above a kilometre, above 2 kilometres, that there's a need, or it's useful having channels 5 and 6. There is a difference. But actually, when you come close in, when you're doing distributed networks of a few hundred meters, channel 5 and 6, the advantage of the oxygen absorption in that is not that impressive. It's not that useful. By the time you're at 200 meters, there's maybe a dB difference between channel 4 and channel 6, because it is a per kilometer. The actual way rain attenuation works in those first few hundred meters is more exponential. So it's actually the rain absorption and planning that you have to do using Link Planner shows that channels 5 and 6 aren't that useful. But I can understand things like the long range. If you want to do the 20 kilometer type things, which will then fall apart as soon as it rains, those things are quite useful.
Perfect.
Hey, Anthony, somebody asked a question about how you can achieve the, sorry, Matt, I had the questions up here. How can you achieve a link with V3000s beyond 600 meters? And will there be an alignment tool to help with the alignment of those longer paths?
Well, whoever Anonymous is, he's my straight man, because that's perfect for the release that was released just today. Release 1.2 that went live today has an antenna alignment GUI in there. So what this is the ability to see how your beamforming is working. 2 phases to aligning a V3000. First of all, you have to physically, manually make sure it's pointing in the right direction, right? So it is a 2 degree, plus or minus 2 degrees. You've got to get it within. You can easily do that using either a telescope, using a telescope mount, or we've actually just introduced a alignment tube, which is just a very simple extruded tube which you attach to the radio, look through, and you can align that. That gets you within that 2 degrees. You can then use this GUI. You can then use, this week, we'll be releasing CN Archer for 60 gigahertz, which is Cambium's network installation tool, which works on a phone. It'll be available for both iOS and Android. And you can use that to then align the radio to get an accurate alignment. But this V3000 is something quite unique to 60 gigahertz radios. It does actually have beamforming in there. It will actually find the best beam to use and adapt itself if it ever changes between plus or minus 2 degrees. And that's something you won't see on any other high gain antenna, 60 gigahertz antenna.
Perfect. And we're running a little short on time, but I do want to express, at CTI Connect, all of our sales staff are CN Wave Sales Solutions certified. So we'll be more than happy to help you out with your network design. We also have wireless engineers on staff. So feel free to funnel all of your projects to us, and we'll get the appropriate people from Cambium looped in on the project and make sure that you're getting the right design and the right assistance. And we'll also walk you through the entire Cambium suite, from the Wi-Fi product to the LiDAR mapping product to the management product, and everything that works around the 60 gigahertz portfolio. We're also able to help you finance your larger projects so that you can, delay those cost expenditures instead of having to have them all up front. And we'll be more than happy to answer all your technical questions. Derek, Anthony, thank you so much for your time. And if you have anything else you'd like to say, feel free to go ahead.
Thanks, Matt. Thanks, CTI, and appreciate all the attendees, and had some good questions. So hope everybody got a good benefit out of the session, and certainly Anthony, appreciate all your guidance here and input.
Well, thanks for listening, and we do have a Cambium forum. We will help you on the support line if you have problems, but we have a Cambium forum. So please, if you've got any other questions on there, go there. I often will be on there, and I will answer questions. I would also say on the poll, I think it was around about 12 or 13 people that's either never used Cambium kit. We have the starter pack. I strongly advise you take a look at the Cambium starter pack for CM Wave and get playing with it.
Absolutely. Thank you very much. If you reach out to CTI, we'll get you all the information in the Cambium starter pack. It's an amazing deal. And everyone, we wish you a happy holidays.
Bye.
Thanks, Matt.